Welcome back, everyone. The topics today are fairly narrow. It's primarily around cancer. So we're going to have a fairly lengthy discussion about that today. And if anyone has any other questions, I want to thank everybody for still submitting those questions into AskSam@velasta.net. At the end, I'm going to talk about two other technologies very briefly, and if there's interest in those, we can do a separate session on that. Some of the questions that I get as a general category are, can you use inflammation markers to indicate your predisposition for cancer? This is a Nature publication. The National Institute of Health has also published papers on this. But the conclusions that I've been able to draw from all of those is that raised inflammatory markers are associated with cancer and may predate the diagnosis up by several months, especially in older patients, male patients, and those with very high and persistent abnormalities. So keep your inflammatory markers monitored at a minimum of quarterly. Your CRP needs to be less than 3. Your SED rates should be in line, but your doctor is going to know several other inflammatory markers that they can test for. But it is most definitely and proven here in these papers that your inflammatory disease state is very indicative of your predisposition to getting an inflammatory disease like cancer, like heart disease, like Alzheimer's, Parkinson's, type 2 diabetes, irritable bowel. They're all pre-indicated by these cancer or inflammatory markers. The other questions that I get is, how does astaxanthin affect the, how does it actually kill the cancer? So far, the research has indicated several different mechanisms. Once the astaxanthin, which is listed here as ATX, penetrates the cell membrane, it definitely has an effect on all of these pathways. So you can see that cancer has a lack of cell apoptosis. It doesn't kill itself. Actually, cancer is immortal. The cell growth and proliferation issues associated with cancer, astaxanthin interrupts that also. And then the cell apoptosis leading to necrosis and final death of the cancer cell. So all of these pathways can be reviewed and monitored, and astaxanthin, we now know, affects all of these. For our part, we've identified two pathways of kill. One is on the PD-L1 or the tyrosine reaction with the C-terminus end of the tyrosine. So there are, in fact, some chemo drugs that interfere with the tyrosine kinase pathway. The other mechanism of kill, unique to Velasta, is its ability to actually penetrate the cell at a very high efficacy rate. With the glucose attached to that astaxanthin, the cancer loves sugar. It primarily lives off of that. So it'll pull it into the cell. Once it's inside the cell, it will truly affect each one of these pathways. Each cancer is different in which pathway allows it to be classified as a cancer. So the fact that this has a broad spectrum attack means that a wide variety of cancers can be attacked successfully at different levels of success with the astaxanthin. These are a list of some of the cancers: colorectal, lung, prostate, oral, esophageal, bladder, leukemia, hepatocellular, renal, melanoma, basal cell, inflammatory breast cancer. The liver cancers, and the hepatocellular cancers are quite affected by astaxanthin dose. Now, one of the things that we have found is that a single dose for all of these cancers, a single specified dose rate for all these cancers may not be appropriate. We now have people taking very, very high doses with extremely positive results. Some folks are up to 500 milligrams per day and seeing tremendous effects. So we are now looking at the dose response curves to figure out which cancers specifically respond to a much higher dose. And therefore, astaxanthin is an extreme example of how a supplement can, in fact, inhibit the growth and proliferation of cancer cells. Desiree asks, I've been on Velasta for 3 months. As of today, no other drugs. I have metastatic breast cancer, triple negative. The key enzymes responsible for ECM breakdown are matrix metalloproteinases. To date, 23 MMP genes have been identified in humans, and many are implicated in cancer. ECM degradation by MMPs not only enhances tumor invasion, but also affects cell behavior and leads to cancer progression. Desiree, you've definitely done your homework. Does Velasta work on HER2 and triple negative? As of a couple of days, I've been experiencing some pain in the affected breast, not consistent, but a sharp pain every now and then. This whole concept of extracellular matrix and the matrix metalloproteinases is very important when we start looking at some of the more severe cancers. Breast cancer is one, pancreatic is another, glioblastoma is another. And so there's a lot of drug therapy being done now to target those very specific genes. There's some out there, for example, the tyrosine kinase inhibitors, things that will stop the proliferation of the growth of the cancer. Always remember this: cancer cells, most people look at cancer cells as parasitic. They think there's some sort of worm or organism in them that they have to get out. They've got to get out right now. The reality is the cancer you have is your cells. It is you. The problem that we have with cancer is that cancer is a runaway in that it continually produces proteins at a very, very high level. It is anaerobic in its nature. It generates additional free radicals. It operates as more in an acidic environment than an alkaline environment. These things we all know from a 35,000 foot level. So cancer itself usually causes death through impingement on other organs or other tissue, or pain, and opiate death from mitigation of the pain. So with cancer, it's easy for me to say, but oftentimes we have to take a very deep breath and look at the attack in a rational manner, out of fear oftentimes, and oncologists have a tendency to promote this more. They immediately install fear. There's something in you that's going to kill you, and in some cases that's true, but in most cases it needs to be stepped back and rationally addressed and look at each and individual case. Here's an article regarding MMP activity in triple negative breast cancer cells. I can get you this paper. You can also Google it. But it says here in the abstract, astaxanthin is a non-vitamin A carotenoid that has gained wide acceptance as a dietary supplement. This paper investigated whether astaxanthin was effective against invasion and metastasis of triple-negative breast cancer cells. We determined that astaxanthin decreases invasion of the 4T1 cells through the matrigel, but does not affect proliferation. Using decreased MMP, using zymography, we showed that 4T1 cells treated with astaxanthin demonstrated decreased MMP2, 9, 13 activities. Western blot analysis conditioned media and lysates suggest that decreased MMP activity results from decreased protein expression. Like I said before, cancer expresses a lot of protein production, and those proteins have a tendency to populate your cardiovascular system and can cause some real serious issues. Using a broad spectrum MMP inhibitor, we observe a decrease in the invasion of 4T1 cells similar to the decrease seen with astaxanthin treatment, suggesting that invasion of 4T1 cells is at least partially MMP dependent and that astaxanthin may inhibit invasion via downregulation of MMP activity. This is one of the reasons that astaxanthin is so important in your triple negative treatments. It has a non-side effect. It affects the STAT3 pathway. We know these things now. The NIH has published several papers on this, and the science is pretty well understood. The proteins generated, like I said, by the cancer can cause coronary blockage and plugging. So there's another question later on. I'm going to answer that one also. But here in this article, and you could pull this article up, astaxanthin is a marine-based carotenoid and accessory pigment in plants, in that it has many different potential functions. Astaxanthin is an antioxidant that is notably more potent than many other antioxidants. Antioxidants have anti-inflammatory and oxidative stress-reducing properties to potentially reduce the incidence of cancer or inhibit the expansion of tumor cells. In this study, we tested the hypothesis that astaxanthin would inhibit proliferation and migration of breast cancer cells in vitro. We found that application of astaxanthin significantly reduced proliferation rates and inhibited breast cancer cell migration compared to control normal breast epithelial cells. Based on these results, further investigation of the effects of astaxanthin on not only breast cancer cells, but other forms of tumor cells should be carried out. This is more confirmation that we're on the right track in understanding how to stop the cancer cell proliferation. She also states, I have heard you say that sometimes where tumors are dying off, there could be pain. How do I know for sure this is the case? Should I take another blood test or PET scan? When the cancer cells die, there's really just a couple ways at which that debris can be cleaned up. And one is your lymphatic system will pull out a lot of the protein material and the cytoplasm and protoplasm that's inside these cancer cells, and they're fairly large. When you look at a tumor cell from a mass point of view, there's quite a bit of material there. How does that material get out of your body? Well, it's either going to be carried out, broken down by dendritic cells or T cells or macrophages, and all of that debris and those amino acids are either going to be absorbed by your body and used, or they're going to be pushed through your lymphatic system, which will cause lymph node swelling, or in some cases we see cysts forming around the debris that's left over. It's sort of extracellular matrix. It can be collagen around the tumor cell, a scar basically, but there's necrotic tissue still residing in the center of that. And in some cases, it'll push it right to the surface of the skin. It will burst open, sort of like a boil, and the fluid will all sort of run out. It's a can be a very scary thing to watch because this red bump will pop up, and given enough time, it'll form a boil, burst open, and all of the guts of that cyst will ooze out. It's not a pleasant thing to watch, but it's actually quite therapeutic. And if you can keep the infection rate down, that means all that necrotic, those dead cells, are being expelled from your own body. In the liver has to process most of that material. So here's a list of symptoms that people are now experiencing and feeling loopy: lymph node swelling, rash, hives, blurry vision, stomach upset, pain in any number of places, and sometimes it moves around, flu symptoms, runny nose, watery eyes, loose bowels, disorientation, focus problems, headache, irritability, hunger, thirst, body odor, itchy, things smell funny, too hot, too cold, fever. There's probably more. This is just a handful that have been recorded during cancer treatment of people that experience these things as their cancer is being destroyed. Keep in mind that when the cancer is destroyed, and we see this in lytic lesions in the bone, when the cancer dies, it was occupying a space in the bone mass itself. When the cancer dies, a hole forms because the cancer is no longer there. So your body will try to fill that. Your nerve endings will try to come back. It's a very painful, long-term process. But that pain is not you dying. That pain is simply from a healing process, the same as you would get an itch on a wound on your hand, or from a burn. It always seems to itch. The nerve endings are starting to come back. So it's very difficult to determine, other than your quality of life will improve if the cancer is no longer impinging or putting pressure on adjacent tissue or organs. So concern yourself with your quality of life, not the fear of what's happening. Here's another paper differentiating between cancer and inflammation. How can you tell from a scan? The reality is a PET scan, an MRI, and a CT scan cannot differentiate between cancer and inflammation. And the scientific community is addressing this. These are papers that have been published. There's a lot more, but the abstract I pulled off here. One of the main limitations of the highly used cancer imaging technique, the PET CT scan, is its inability to distinguish between cancerous lesions and post-treatment inflammatory conditions. This is getting a lot of people harmed. And when the oncologist cannot differentiate between your cancer appearing to grow and or the inflammation is attacking your cancer, destroying it, and your inflammatory response will show a very similar image, their first response is to give you more chemo, more radiation, to go in and do surgery. The reality is that may not be the issue. Time has to be accounted for here, and your inflammatory markers need to be addressed. Your CA numbers may increase dramatically upon a cancer kill, whether it's from chemo or whether it's from Velasta, and that always causes concern in people. The reality is those proteins that make up those cancer antigens are going to be released when the cell membrane bursts open like a water balloon, and all of that material all of a sudden floods into your bloodstream. Now when you test, your cancer markers are going to be astronomically high. But as I stated before in the last one, it should follow a bell-shaped curve. You should see an increase in CA if there's a cancer kill, a pretty substantial one. It should bend over and then start to come back down the other side of the hill. That can take anywhere from 2 to 6 months to observe that effect. But it all hinges on on your quality of life. So keep that in mind when you're going through this. Nicole asks, which cancers does Velasto work better for? Surely by now there must be some evidence leaning heavily with proof that certain cancers respond better than others. For example, I've read many testimonies that hormone-positive breast cancer does not. Even people taking this for over 4 to 6 months and longer having a lot of progression while on it. However, we never hear anything about triple-negative breast cancer, specifically stage 4. I've heard you address the PD-L1 aspect, but many women that are stage 4 triple negative are not PD-L1 or I think she means PD-1 positive. Can you address this as well? Once we get to stage 4, it's very difficult to get ahead of, really to get ahead of anything. But the good news is we have probably several hundred people who have done or have been classified as stage 4, shown complete kill of the cancer to the point of non-detectable. So with some of these cancers, depending on their ECM, their extracellular matrix, the ability to get into those cancer cells, the longer that you have it, the more difficult it is. But there are ways we're finding now through what's called concentration gradient, where when we increase the dose, we push more through that extracellular matrix. It seems to be working. We have several cases now in the UK where they just unilaterally increase their own dose up to 20 pumps a day with pretty dramatic results. They see the cancer turn and bend over. So this may be more of a dosing issue, and we are probably looking at the effects of increasing the dose and trying to observe what happens in those cases. Errol asks, this is my 4th day since starting, taking 10 pumps of Velasta each day. The only thing I've been noticing is I find it hard to keep my eyes open. I felt like returning to bed at midday. Could Velasta have a role in this? I sleep well at least 8 hours each night. I take Velasta because I have enlarged prostate, which is not allowing me to drain my bladder. Even with a catheter, at times I have difficulty passing urine. Professor Thomas Seyfried, in his book, Cancer is Metabolic Disease, writes there are 2 main fuels feeding cancer, glucose and glutamine. First one is taken care of by ketogenic diet. Second one is glutamine. Would you like to comment on the second cause, glutamine, and how can it be controlled? He's absolutely correct. The only problem in his statement is that the glucose production can be controlled through a ketogenic diet. 80% of the glucose that your body uses is generated by your liver in what's called glycolysis. So if most people go to bed at night, they wake up about 4 o'clock in the morning, between 3 and 5, a light sleep. Some people get up and go pee. The reason that is, it's called the a dawn phenomenon. We see it with diabetics. It's something that people need to understand. After you've had your supper, say around 5 o'clock in the evening, you've now gone 11 hours and not eating. Your blood glucose levels will drop. That's an indicator for your liver to start producing glucose or sugar. And it produces it in the liver in the conversion of glycogen into glucose. Your cells need the glucose for energy. And when that happens, your glucose level goes sky high. In diabetics, often doctors tell their patients to measure their glucose levels the first thing they get up in the morning. It'll be sky high. And it justifies them remaining on their insulin. The best time to take your glucose is 30 minutes before you eat lunch to get away from the dawn phenomenon issues. Now, what happens at 4 o'clock when your glucose level spikes? Let's say it's a non-cancer patient. You'll go into light sleep. You'll wake up. your muscles will now move, your brain activity picks up, your brain frequencies, the alpha, beta, and gamma frequencies in the brain begin to get excited, and you usually wake up, your legs work. In REM sleep, for example, when in deep sleep, you're paralyzed. But when the sugar level increases from your liver conversion, then you become sort of energetic and you begin to wake up. So in the ketogenic diet, always keep in mind that cancer has priority over any glucose in your body, whether you eat it or you produce it. Like I said, 80% of the glucose used by your body is produced by you. If you cut all the sugar out of your diet, you would still survive, and simply because it would live off of the fat stores in your liver, the glycogen inventory that your body builds up. Glutamine is a different issue. Glutamine is an amino acid. It's extremely important in our bodies, extremely important in cancer cells. Now, if you try to develop a glutamine inhibitor, it's going to have a toxic effect, a very extreme toxic effect on the other cells in your body. Your heart muscles are going to die. Glutamine is what makes up the G in the latter rungs of the DNA. So, but glutamine is also something that cancer has to have because of its prolific growth rate, and its ability to produce these proteins. So glutamine is one of those that to date we have no way of inhibiting glutamine production. There's not a drug you can take, there's not a chemical, there's not an inhibitor. It is absolutely necessary for your very existence. Trying to inhibit it will cause your death. Your DNA will unravel, more cancer will probably result. So the elimination of glutamine is right now of interest as a target, but there's nothing that can be done to inhibit it. So that is a little bit of an issue. KC asks, I take your product as a preventative. I was talking to someone the other day, he was a doctor, and they were saying that astaxanthin clogs arteries. Can you help me understand why they would say something like that? Okay. Ignorance is alive and well, even in the medical community. It's all about money to most. This is absolutely irresponsible for a doctor to say that. There's no basis of this at all. Now, one of the things that he's leaving out conveniently is that astaxanthin will kill cancer cells. That's been proven. There's thousands of articles written on it from the National Institute of Health. Now, it's not the astaxanthin that clogs the arteries, but the protein released during a cancer cell kill can plug the lymphatic system. We have no indications, not a single case since 2013 of astaxanthin clogging arteries. To the contrary, we have several cardiologists now looking at astaxanthin to stop the blockage of coronary arteries. Here's a paper that was just published. It eliminates cardiovascular disease. So whoever this doctor is, he took an oath against nihilism in that he's forbidden to, under his practice, to talk about things he knows nothing about. And he obviously has violated that Hippocratic oath requirement. So there is no evidence at all or justification for this doctor to even say this. Kathleen asks, on another video I mentioned the synergistic effect of immunotherapy and Velasta. Which immunotherapies have you seen have a dramatic effect when combined with Velasta for ER breast cancer? Here's some of the ones that have currently been used together with pretty intense responses to the point that oncologists cannot have an explanation as to why the chemo drug itself was giving these types of results. Most of the people, gemcitabine is one. This is a chemo drug that's used for pancreatic cancer. There's some NIH papers, research papers now that have been published with this. Keytruda and Opdivo were both compounds. These are PD-1, PD-L1 inhibitors. They act in conjunction with Velasta. There's no contraindications with these at all. Most of the immunotherapy drugs that end in MABs, MABs, and Velasta seem to work quite well, and they seem to work in synergy with each other. And to date, we're not seeing any side effects. Now, some oncologists are arguing that antioxidants have to be eliminated when you're doing chemo, and the reason being is that the chemo, the Plaxitaxel and some of the heavy metal-based chemo drugs generate a huge inflammatory response to kill not only cancer, but it has a very high, an 87% chance of mutating normal cell DNA that will later on represent as cancer. So current chemo is a shotgun approach. It generates a huge number of reactive oxygen species bullets that are not specifically targeted for cancer. They will also target normal cells. If a PET scan won't be able to tell if my cancer is dead or alive, how would I know if I should try helping the Velasta with an immunotherapy, or Velasta should be continued alone, or just wait? I'm taking an approach because I'm aware of several cases where now chemo drugs were prescribed, and it was probably an inflammatory response. And they probably did more harm than they did anything else. They cannot differentiate between what it is. We have to look at things like trends with the CA numbers following that bell-shaped curve, and that takes time. If you're looking for a quick fix after you've spent 5 to 15 years getting cancer, cancer doesn't operate that way, and neither does the treatments for cancer. So it's going to take time for these processes to work. The idea is to prevent yourself from ever getting cancer once we get it eradicated. Velasta is a great preventative at a small dose. So let's work on prevention, and so we don't have to work on cure, because not everybody responds the same way. There is no 100% magic golden bullet that's going to save human life. Nobody's getting out of here alive. So everybody has got to come to that realization, but it's the quality of life that we want to strive for. And this is but one of those that can really improve the quality of your life. In a previous video, you commented that vitamin D is a pro-oxidant like vitamin C. I have over many years increased my dosage of D3 to 28,000 international units of D3 and go out in the sun as many days as possible to finally get my 25-hydroxy up to 80. I'm taking life extension cholecalciferol and use the best brands I can find, including Thorne. Am I causing my own cancer by taking D3 at this high dose? D3 is very, very important for fixing calcium in your bone structure. Now, if your C-reactive protein is above 3, then you need to cut these inflammatory vitamins out or reduce them in quantity. The indicator is going to be your ESR or your CRP measurements. As long as you're under 3, then I don't care what you're doing, your inflammatory disease state is such that you're probably not, from a probability point of view, going to experience an inflammatory disease. Now, D3 also has the other implications, is that it stops the viral attacks. All during COVID, it was very important. The ACE2 receptor in COVID needed to be blocked because that's how the COVID virus made entry into the cell. So these are all things that that D3 can do very, very positively. In the discussion of heme in meat, he discussed iron and how Velasta allows it to be taken out of the body through the liver and through the bowels, but I'm still not clear whether I need to stop eating iron-containing foods such as beef, bison, or if the Velasta counteracts the cancer thriving from the meat. Iron, as we get older, iron accumulates in cancer cells and allows for the proliferation of the conversion of peroxides in the presence of iron into hydroxyl free radicals. That lowers the pH and allows the cancer cell to proliferate. Iron in any form, whether it's plant iron or beef, and coming in the beef form, we need to think seriously about if your iron levels are running high, your ferritin levels are running high, then especially ferritin. If your ferritin levels are running high, then that means that you have excess iron and you're storing it in the form of ferritin. And when you do that, it's accumulating in your bloodstream now. Well, that iron in that ferritin will also generate free radicals through what's called the Friedel-Crafts reaction. And that will cause a pretty high inflammatory response. So if your hemoglobin is normal, your ferritin levels are high, it means that you're not producing enough red blood cells to fix the heme iron, and it's accumulating as ferritin in your bloodstream. And high levels of ferritin in the bloodstream are very, very negative. Now with that, I'm going to close for right now. Keep the questions coming in, but there's two other technologies that I want to tell you that we are currently developing. We also have Velasta for animals. That's not one of them, but we do have that also. The other one that we have is what's called VLED, V-L-E-D. It has a website, www.vledusa.com. And for those suffering from Alzheimer's and Parkinson's, take a look at that. I'm going to do a special on it and explain how that technology works. It does stop the progression, or appears to stop the progression of Alzheimer's. And we have over 400 of these out now, and the results are pretty astounding. But I'm going to explain more with that. The other one, I got a lot of inquiries regarding the possibility of working on some fuel substitutes to improve gas mileage. Not quite in the context of what we're talking about here, but in my overall context, it's something that's been very dear and very important to me. We do now have a compound called Interburn. Interburn is it's 1 ounce for 20 gallons. It'll give you up to about a 20% increase in gas mileage. And in light of everything that's going on right now, it's a pretty good. It's really a good product. Works very well in diesel, gasoline engines. It's something that I'll be talking more and more about. There is a website called Interburn, E-N-N-E-R-B-U-R-N. Take a look at it. I've used it in my own vehicles and got a 18% increase in gas mileage. And there's no doubt it works. It works much better in diesel vehicles, so long-haul drivers should be looking at it very, very seriously. And with that, I'm going to close. I would like for everyone to keep sending in their questions. And we're now across the world. We've circumnavigated the Earth. We have people on this basically in right now in 27 countries, I believe. the results are pretty amazing. I'm sort of at a loss as to how far this has gone, but I think we've hit what is actually causing human disease now. We now know that. So keep your questions coming in, and look forward to next week's talk on Alzheimer's, Parkinson's disease, and ways that we can prevent it. Thank you so much, and looking forward to hearing from you.